Hello, this is part 11 of our game making tutorial. We have been hopefully doing some stuff that wasn't too difficult. We've been kind of going over a lot of the same code stuff that we would know how to do. Destroying instances, creating instances, learning the difference between instances and objects, and messing with timers. We've done loads of that. It's time to get to something that will be much trickier and much less fun, but you do kind of have to know it. It's collision, the worst thing in game development. I've rewritten the collision system for Gunpoint about 8 times, I think, and it still doesn't work, really. It still breaks in the final shipped game that we sell. It's possible to teleport through walls, it's possible to get stuck. Collision is just very, very fiddly, and it's fiddly because, as we've seen, games work in discrete steps. There are only so many steps per second, and it can be 30, it can be 60, you can crank it way up to 120 or whatever, but ultimately things are not moving smoothly. They're moving in juddery little things. And it looks okay to the naked eye, but the question of have you hit something yet or not is problematic. Because it's perfectly possible that one frame you haven't touched it at all, and the next frame you're already through it. And that's what makes it tricky. And when things are moving around, rotating and sliding against each other, it gets even more tricky. So we're going to start simple. Our game, we've got bullets, we've got enemies, and we've got us. Those are the bits of people as well, I guess. So let's write... there are several things we might want to do for each of those things. And I think bullets are going to be the easiest. So on a bullet, when a bullet hits a wall, what do we want to happen? We actually just want it to be destroyed. So we'll just say if place meeting, so this is a new term. Previously we've been saying instance place, and then we've been getting the identity of what we've hit. In this case, when we hit something solid, we don't need to know what we hit, we just need to know we hit something solid, and it's all over. Life is over. So we're going to say something like if place meeting xy and then a solid object, so like it might be called oSolid, and if that's true, then instance destroy. Now, that's all pretty straightforward. So let's make our solid object. Probably should have done this first, really, but we'll create a new sprite. Sorry, not load sprite. Edit sprite. New. Let's make it 64 by 64 because it's nice. 32 by 32 is tiny. Make it black, say OK to that, call it sSolid, and we'll put the origin in the center just because that's what we're doing for everything else. Then we'll create a new object, we'll call it oSolid, give it the black sprite thingy, and let's go into our room and place some. So I might get rid of some of these enemies because we don't want, it's going to get fiddly to like design a level around them. Enemies will spawn once the game starts anyway. We could leave one of each type, I guess. Can I drag that one around? Yeah. The room editor has changed quite a lot since the version I made Gunpoint with. Actually, while we're at it, let's move the weapons to be closer to us, because it's a pain in the ass to walk over there. So now we go to objects, find a solid object, and we'll place them in the level. This is like how you make rooms, really. You can make them out of individual blocks. If you're having if your levels are always going to be these big, long, straight walls, you might want to make a big, long, straight wall object, so there's only one object that things are checking against. But it's not hugely important. Well, you'll know if it's hugely important when you do that in your game. If you make everything out tiny, tiny blocks and it starts to slow down, that's probably the cause. But these things, because they're blocks, that's the easiest thing to deal with collision on. Finding out whether something hit a square or a rectangle is the easiest thing Game Maker can do with collision. Hey look, that already works. Perfect. So our bullets, when they hit it, they just die. And that, it looks right. I can walk straight through it. In fact, I get camouflage, which is kind of great. And these bullets can go straight through it. Enemies can go straight through it. And so that's a problem. So, let's call that, I think actually bullet's probably the only thing that will be destroyed when it hits a wall. Everything else will have it stop. So how about those liquid shots? That when they splurge out, it's important where they land, and it's important, once they're on the ground, they still have gameplay relevance, because you can shoot them and blow them up, and that makes a big difference. So I think having them disappear when they hit a wall is kind of cheap. We should have them stop when they hit a wall. So we're going to do that. It doesn't really matter if they don't stop exactly on the wall. It would be bad if they went through it though. So we'll have it, we'll put this fairly low down in the code. Probably not before we're destroyed. In fact, yeah, up here then. And we will say, actually no, let's have it way up top. Yeah, because all this stuff depends on our speed, this stuff here, but it doesn't affect our speed, it doesn't increase our speed at least. It can decrease it here, but that's it. So what we want to know is, if not, this time we don't want to know did we already hit a block, we want to know are we going to hit a block. Next frame will we hit a block. So we'll say if place meeting, instead of x and y, we'll say x plus h speed and y plus v speed. Oh, solid. And if that is true, we'll just say speed equals 0. So we're just literally, if we're about to hit a block, stop. Now this can stop us short. Maybe, you know, we're 3 pixels away from a block and our h speed is 6, and in 6 pixels we would hit it, but in 3 pixels we wouldn't. And this will say stop right now, so we'll stay 3 pixels away from it. Like I say, with this particular object, I don't think it matters because that's not a huge deal. But for the player, that would matter. And we'll get to the player next, I think. Or should we get to enemies next? What am I doing? Oh yeah. So, oh yeah, it just stops. Oh, that's really nice. That looks great. It's all kind of just accumulating around it. So I figured just stopping that would look okay, and it does. Yeah, let's do enemies next, because we'll work up in order of complexity. Easiest thing is something that just kills itself. Things that kill themselves, God, they're so great. At the end of Gunpoint they said something to the effect of, the next game we're making, when 2 things collide, one of them's going to get destroyed. Because that solves all your collision problems. And then things stopping, pretty easy, as long as you don't really care exactly where they stop. These things are fuzzy and they're fading out and they're quite big and chunky and they overlap each other, so you don't notice that they're not stopping in the exact right place every time. The player, it does matter. Enemies, it doesn't matter too much actually. So let's do the exploding enemy first, there seems to be more of those. And we'll do a similar thing. We've actually previously called a script bounce off walls, which is almost exactly what I'm about to write. What we meant was bounce off the edges of the room there. We could change that. I'll change it later. So we can do the same thing. If place meeting x plus h speed, y plus v speed, solid. We've only got one solid object right now, but if we made more, we could make them all children of the solid object, so that they would all count in this check. Then, what we'd quite like to do, we want to bounce off it, but it gets tricky if you say, it's surprisingly hard to pick an angle that you know for sure won't keep pushing you into the block. So, in actual fact, this might work. I was going to do a more complicated way, but I think this might be all we need. If we say, if we reverse direction, if we did direction plus 180, then that would work. We'd always go, we're coming towards it, whatever angle we're coming at it from, if we totally turn around, we know that path is clear, because that's where we came from, unless there's blocks moving around, but I'm not dealing with that. But they will look weird to kind of just go back like that. That's weird. But what if we just added 45, so that that's like, what's halfway to 90 degrees, so it's a turn like that. Obviously that might still be blocked. If we're about to come into this wall, like we're right next to it and our speed would take us all the way in, then turning 45 degrees to the left might still take us all the way in. So yeah, I'm trying to decide how to do it. So I'll just show you what I was going to do. I was going to say while place meeting, while there's something in our way, keep rotating 45 degrees. So we'll just keep on doing it until there's a free spot, and we can be pretty sure that there will be one. But let's try it with the if statement. Because there's several advantages of doing it this way. One is if it works. If it doesn't work, there's no advantages. One is that it's quicker. We only do one check this frame, and then if next frame that direction is still going to make us hit something, we'll rotate again anyway. And it also means we can't get stuck in an infinite loop because this doesn't loop at all. So the problem might be that we rotate, then we add that speed, and then when we rotate again, we're actually inside the wall. We'll see how it works. If this breaks, then we can do the loop, but we can put a limiter on it so we don't get stuck in an infinite loop. Oh, in fact, haha, no, it's okay, the infinite loop will be a problem. Okay, so he bounces off quite nicely. We need loads of them though, don't we? We want to see this happen lots of times. Meanwhile, I'll make a sludgy liquid wall. That seems pretty good. So I am going to do the while loop, and what the hell so my little like aha moment just then was this is direction plus 45, and therefore 45, like I said, is half of 90, which means if you do this 4 times, you'll be going direction 180, and then you'll be going back the way you came, which is a good direction. And because it's all in this loop, we're doing it all right now, we haven't moved at all, we're staying in one position, we're checking, can we go this way, can we go this way, can we go this way, and eventually we'll come back to the direction we came from. And so that, in theory, can never fail. If we did put moving blocks in later, or if we created blocks, then this could get stuck in an infinite loop. So we'll put a limiter on. We'll just say, what should we say? Let's just say collision checks equals 0. And here we'll say while there's something in our way and collision checks is less than, which is certainly, in fact, we should never really do more than 4. So, well, I say, yeah, less than or equal to 4. So if collision checks has gone too high, then we will stop this even if we haven't found a good route to go. Because it's better that we get stuck in a wall than crash the game. Because if this loop never stops, then the whole game crashes. And even if there's stuff moving around, it will still crash because it will never leave this loop, so the other stuff doesn't get a chance to move out of its way. So that's why putting a loop limiter on is worthwhile. And here we'll just say collision checks plus 1. So each time through we increase this thing, and once it gets to 4, once it gets to 5, we will give up and we'll just keep moving. So let me check that works. And then we could just actually put that in our bounce off wall script. I should put more walls in, shouldn't I? Yep, that works. I really like this. It's like a wall of death. Yeah, let's just put that, let's make that part of our bounce off wall script, because that's what you would think a bounce off wall script should do, right? That currently bounces off the edge of the room, bounce off edge of room, and this one is bounce off solid objects. We could try and combine them, but it's not worth it. But our old code works for that, and our new code works for the new thing. And now, because we put it in that script, the other enemy that also has the same behavior, also bounce off walls, now he's got that too. So that's good. Both our enemies have bounce off stuff now. Let's go and play some more objects. Because what we want to do is test whether things get trapped or things behave weirdly in any way, really. Something like that would be cool. And we'll place a few just dotted around too. Look, it's a level! We're designing levels! So, next, I think we can't put it off any longer, we've got to do the player. The reason the player is a pain in the ass is, let's try, so with the liquid shot, we had a bit too much white space in that, I think. If we're about to hit a block, we just stop. Actually on the player, so we could paste that into here, and we will want to use things like h-speed and v-speed, that's how we tell whether we're about to hit something. But if you remember the very first time our very first lesson ever, we did speed with our own variable, we manually changed the distance. Technically the player has no speed. If we checked what speed was, it would come back as 0, even when we're moving, because technically GameMaker's own speed is a separate thing. And so really we should change this to use that. We can still keep the my speed variable. What we'll do is, instead of manually modifying our y position, we want to say h speed, sorry, v speed equals negative my speed. So we don't modify y and x directly at all now. And that's actually, it's a good thing to get done anyway, because when we do checks like this, we are checking, when we add our speed onto our current position, where will we be? We expect that speed to take into account all the changes that we're going through. And right now it doesn't. There's a secret hidden change where we manually modify our x and y value independently of the speed variables. And that's a bad thing, bad habit to get into. Is that right? Yeah. And so we want v speed equals plus my speed there, and here we'll do h speed equals negative my speed. I think that works, just putting minus in front of a variable. I read that in the help today. I've never used it before, but we'll see. If it breaks, it should be obvious how it's broken. So now our v speed and h speed things will be set correctly. The only other thing we need to do here is, if you're setting a speed, you've got to remember that that speed won't ever go to 0 until you tell it to. So right now, I mean, okay, if we hit something, it'll go to 0. But if I release the key, it should go to 0, right? If I'm not pressing W or S, then I don't want my v speed to be anything. I want it to be 0. So at the top, before we do this, we should set it to 0. But we don't need to set v speed and h speed separately. We can just set speed. Speed equals 0. So before we press anything, set speed to 0. Then when we press things, modify our h speed and v speeds individually, and that will take it into account. So hopefully this movement will behave just as it did before. This new code is just the same code as that's on the watery shots, liquid shots, and it will stop us when we're about to hit something, but it won't be very elegant. I'll show you why it doesn't feel good. So there's quite a lot to test there. Let's take this time to check if it's working. Yeah. Okay, so our movement keys still work, but it's hard to actually show you what's wrong with this. But when see, it looks like I'm getting stuck on the wall. I am getting stuck on the wall. It's really annoying. But actually, like stopping dead, it's pretty good, isn't it? Like we don't stop a long way from the block. We stop pretty close to it. I would say that's good enough. But for movement, for the feel of the game, it's really bad because if I am moving diagonally like this, I stop dead. I'm still holding up and I'm holding right, and I could be moving up, but it's not letting me because it's just calculating, oh, there's something in our way if we had both our speeds going. But if, and so we're stopping you dead, but in fact, we should be letting you move. We should be letting you move in the direction you can move. Oh, yeah, that's pretty bad. There's also another problem, which is I'm holding down right at the moment, and as you can see, I'm going. I'm sometimes moving and sometimes not, and that's because we're rotating. Like when we move the cursor, the player is looking in different directions, and that's causing the actual collision box for our, or collision ellipse for our guy to rotate. And in fact, even if we made it perfectly circular, rotating it still changes the collision a little bit. There's still little like rounding errors and stuff in the way things are rotated that mean it will never be perfectly smooth and perfectly consistent while our actual physical body is rotating with the mouse. So we cheat. This is the secret to almost all collision stuff, is you have to cheat. You have to find some hacky way around it that doesn't require games to work smoothly and perfectly, because they don't. So that's the first thing we're going to do. We fixed the player's movement. That felt really nice. Well, it felt really nice. It felt exactly as it did before. The point is I didn't break anything. That's always priority number one. But we haven't... we've still got this rotation problem. So what I want, the culprit here, is... where is it? Facing. We say image angle equals point direction, yada yada yada. It's our image angle that determines which way the image is facing, and the image determines the bounding box, the thing that actually determines collision. And you can imagine if we're long, thin ellipse and we're standing next to a wall, and then we turn this way, part of our ellipse is going to clip through the wall, and there's no code that checks that. This h-speed, v-speed thing doesn't know anything about rotation. It has no idea that we're about to rotate. So it can't predict that we're going to hit that, and it can't stop us. And even if it did, I don't know how it would, because we're not saying try and rotate towards the direction of the mouse. We're just saying go there immediately now. Don't check anything. Don't test anything. So I think we want to do that. Actually, we want to face the mouse always. We don't ever want a wall to stop us from turning around. That's really irritating. Even in games where it makes physical sense for that to stop you, they don't stop it because it's too annoying. So let's not change our image angle. We're going to leave our image angle as it is, and instead we're going to say, make a new variable called facing. Facing was point direction that. And now we're going to get into the draw event. So this is not usually directly related to collision, but there is an event called draw. When you go to add event here, there's loads of different versions of it, but we just want the regular draw one for now. And in that event, we're going to add some code. Now, when you have no draw event at all, GameMaker is still drawing something, right? It's still, there's an object, it has a sprite, and it knows you want to draw the sprite. And what it's actually doing is something like draw sprite, sprite index, image index, xy. So that's kind of the code that's running normally on this event. And if you don't specify, if you don't put anything in the draw event, GameMaker thinks, oh, you probably do want to draw the sprite, you just want to draw it normally, right? Whatever the image angle is, you want it to be facing that way, whatever the sprite index is set to, you want that sprite, and so on and so on. And whatever its actual physical position is, that's where you want to draw the sprite. But you could equally put in like x plus 100 here, and now the physical object will still be in the same position, but it will draw 100 pixels to the right. We don't want to do that, that's weird. But we want to draw, what we want to do, I'll put it in a comment. Draw our sprite normally, but facing our facing direction without changing image angle, so as not to affect collision. What? This makes sense. I'm not on trial here. It's always good to justify yourself fully in the comments. So that's what we're going to do. How do we do that? Well, that draw sprite thing, it only takes x, y, the sprite index, which is the name of the sprite, and image index, which is something else. But actually, it doesn't factor in image angle, and we want to factor in image angle. We want the draw sprite ext, which is a really specific function for, we want to draw a sprite and we want to specify every single thing about how that sprite is drawn. And the reason we want to do that, we actually don't care about any of the other things. We want all of the normal position and color and scale and animation stuff. We want all that stuff to be what it normally is. We just want to change the image angle. And instead of image angle, we want to change facing. Because right now, if we ran it, our player would always be looking in the same direction because the image angle isn't being affected anymore. All we're changing is this facing variable, and that doesn't affect anything. So we want to put the facing variable into the drawing logic. And I'm giving this a lot of preamble because it's going to be a monster line of code. It's going to be, what I have to do here is type in a bunch of special words, each of which just means do it normally. So if you look down the bottom here, it's where it is, tells you what the arguments for this thing are. There are loads of them. And it wants to know what sprite we want, what subimage we want, what x and y coordinate we want, what x scale, what y scale, what rotation, what color, and what alpha. And rotation is the only one we want to change. So all the rest I have to write the special word for it. So the special word for what type of sprite we want is sprite index. That is, whenever I change the sprite here, the sprite index will be updated to reflect that. So I wouldn't want to type in, for example, sPlayer here, even though that is our sprite index, because I might change that one day. I might decide we want to have a different sprite. I might even want the sprite for the player to be changing as we play the game, depending on what we're doing. So I just want it to be whatever the sprite currently is, whatever we set it to be, sprite index. And all of these words will be those. I won't be telling it what number or what actual sprite. I'll be telling it just do the normal thing. So for image index, it says subimage down there. Every sprite has a series of subimages. Right now we've only ever done one subimage in each sprite, and they're used for animation mostly. You can use them in different ways, but animation is the most common one. And so we just want It will always be 0, but that variable is called image index. We're putting that in. Now, x and y, hopefully you're familiar with those. X scale and Y scale, hopefully you're familiar with those too, because we used those on enemies, didn't we? To expand them, to contract them. And on the water droplets to expand them. So again, we don't enter 1, it will be 1, and as far as I know it will always be 1, but we don't want to specify that, we want to leave open the possibility of changing it later without having to come back and correct this code. Now we're at rotation, this is what we want. Rotation should be facing. And now it wants colour. And so when you display it, when you draw a sprite like this with the draw sprite ext thing, you can give it a colour, and that means if your sprite was pure white and then we specified red here, then the sprite would come out pure red. Our player is black, so if we specified C red there, the black would actually stay black because it can't get any, it never gets any brighter, it can only get darker. But the white eyes would go red. So it's kind of like a filter. It's like if you hold up a transparent piece of plastic in front of your face, you never see anything brighter than it was before. The most, if you hold a red sheet of plastic in front of you and you're looking at something red, it stays pretty much the same colour. If you look at something white, it looks the same as the red thing, but if you look at something black, it will stay black. And if you look at something blue, it will be pretty dark as well. So that's how that works. But we could put C white in here. A white blend means nothing, it won't affect the sprite. In the same way that holding a perfectly transparent thing doesn't affect what you see. The metaphor breaks down a bit there. So we want the word that means whatever the normal thing is, so image blend. So if we did want to tint our thing later, we could set image blend to something else, and it would update here. And then lastly, alpha is how transparent it is. We've done that before, haven't we? So we just type image alpha. So you don't technically need to know what all of those things are to write this line. All you need to know is the facing thing has to change. But since this happens to be all of the things that can affect how a sprite is drawn, all collected in one place, I figured I'd go through them and actually explain what they are. Particularly because I'm asking you to just basically copy out this massive line of things with so many special words in it. Hopefully most of it is familiar to you now. So that's all good. And our facing is being updated in our step event. We could update it in the draw event, but you're not supposed to put code in the draw event other than drawing things, because the draw event runs slower than everything else. I don't totally know why, but just do what they say. The only thing, so as far as I know, GameMaker always executes the step event before the draw event. So in fact, let's put that to the test and just run it. Because we haven't, in our create event, we don't specify what facing is. It's only set in the step event. So if the step event didn't run, the draw event ran first, our game would crash. So it could be good practice to put it in the create event, just say, hey, initially facing equals 0 or whatever. But as it happens, I guess, oh, look at that. Now we always fire in the same direction. We pinned the guy to the wall. I love that, that's great. And I pushed him in. I forgot we could push them back. So you know why it's always firing to the right? It's because our bullets go by our image angle, and our image angle never changes now. So we're going to close that, and we're just going to update that on the guns. Single shotgun. Our image angle is now going to be owner.facing. In fact, yeah, this could trip us up, because facing might not be defined yet. If our step event runs before the players, actually it never could, but I don't think it can trip us up, but we might correct it anyway. And then wave gun, replace image angle with facing. It's okay for our image angle to be set, because we're not going to do any collision on the gun. And yeah, I am just going to nip into the create event and just say initialize. What the fuck? Facing equals 0. So that just ensures that nothing will ever check facing before it has been initialized, or it has some value. So let's just check that works. This is all prep to make sure our physical shape is not changing as the mouse moves around, because that is a nightmare. Yeah, here we go, we're back to normal. This is one of those enchanting parts of game development where your objective is to get back to what you had before. So, now comes the tricky part. That wasn't the tricky part, this is the tricky part. This code sucks because we get stuck on things, it doesn't take into account our speed, it won't try and conserve our speed, it just stops us dead no matter what angle we're coming in at. So what we want is, we'll keep that part, we only care about this if we are about to hit something moving in our current speeds, but we're not going to stop straight away. What we want to do is, let's say, keep as much of our horizontal speed as possible, and to do that we will do, what variables are we going to need for this? I want to say something like while something, let's do while place meeting, let's say, okay, forget about our vertical speed for now. If we didn't have any vertical speed and we're just moving horizontally, would we have a free spot? So while that equals false, then we want to steadily increase our h speed. So in fact, before we do this, we need to set h speed to 0, and then in here we want to say h speed plus 1. So we'll make our h speed 0, then as we go through this loop we'll increase it by 1 each time, and we'll stop when we've increased it so much that we hit something. But of course there's a possibility we might not hit nothing, because the reason we might have stopped is that we're going vertically and our h speed is fine, in which case this will just keep going forever and we'll get stuck in an infinite loop. Obviously we don't want that. So we should also say, before we set our h speed to 0, let's say old, I'll just say it like that, as h speed. And here we want to say don't go more than that. So we'll say and h speed is still less than our old h speed. If it's reached our old h speed, then we're fine. So this, if you're really thinking this through, some alarm bells should have gone off here, because what if our h speed is negative? Now we store our old h speed in this variable. I kind of hate the way that looks. Old speed. What if I did capital H? Old h speed. Yeah, I'm going to do it like that because it's clear what we're saying. We'd store the old h speed as, say it's -5, then we set it to 0, and then we say while x plus 0 and y, while there's no block there, and h speed is less than old h speed, well, h speed is 0 and old h speed is -5, so 0 isn't less than -5, it's greater than. So we stop right away, we do nothing, because we've already passed it. So this is, right away, this is wrong. I'm going to slightly just change the way this is laid out, because we want to think about these two things very separately. Those are the two conditions under which our loop can stop. And one of them says, check there's still room with current h speed, and this one says, check we didn't go too far. Or maybe more specifically we could say, check we haven't restored all of our old h speed. And right now we're doing a less than check there, and also we're increasing h speed. We're adding 1 to it, expecting to increase it, but actually that might not be increasing it. If it's -5, adding 1 to it goes to -4, and you're getting closer to 0. So it's up to you what word you want to use for that, but it's not what we want in this case. Sorry, we'd be starting at 0, wouldn't we? So we'd be adding 1 to it, and we'd be going 1, 2, 3, 4. Have we hit -5 yet? And you see where that goes wrong. So let's solve it here first, because this is the simplest instance. We don't want to always add 1 to our h speed. Our purpose is we've gone back to 0, now we want to creep towards what our old speed was. Because if you imagine a brick wall here, we've gone here, we've realised, oh shit, if we go for a full h speed, we're going to hit it. So now we want to go back to where we were, and we want to inch towards it until we do hit it. So we want to keep increasing our h speed until we get there, but we want to increase it in the direction it was. So if this is positive, well, that's negative. So if we're going this way, we want to go back to h speed equals 0, which is here, which is our previous position, our current position, I guess. And then we want to creep towards it. And that is going forwards in our language, but that's not necessarily positive. It could be negative. This could be going, here's 0, here's -1, here's -2, here's -3, here's -4. We want to stop at -4. And we can't go to -5 because that's in the wall. So the point is we want to creep in the direction of h speed. And there's a nice little word for that called sine hspeed. Sine, if hspeed is positive, sine will be 1. If hspeed is negative, it will be minus 1. So we'd be saying hspeed plus minus 1, which is hspeed minus 1. But, I told you collision was a nightmare. We can't say that because hspeed is 0. We just set it to 0. And so if it was negative before, now we don't know that because we set it to 0. So we've got to find the old hspeed and take the sine of that. So this now says, set hspeed to 0, then add 1 to it if our hspeed was positive, or minus 1 from it if our hspeed was negative. So this will creep towards old hspeed. We'll say that. So that's good. But this check is still wrong, obviously, isn't it? Because of this hspeed being less than this, that might be a good thing or it might be a bad thing. We don't know, because we don't know whether it was negative before or not. So we actually just care about the magnitude. How big is it? And that's called sometimes the absolute value. And so the function for that is ABS, the absolute of hspeed. If hspeed is minus 5, this is 5. If hspeed is 5, this is also 5. So we want to compare the absolute values of both these things. We just want to say is one of them larger in magnitude than the other. And minus 10 is larger in magnitude than positive 5, but minus 10 is less than 5. In terms of, like, when I say less than, I mean this symbol here. That really means more negative than. So like 5 is less than 10 because it's further in the negative direction. Minus 10 is less than positive 5 because it's further in the negative direction. And we don't want that. We want the more kind of quantity notion of less than. It's a nightmare, isn't it? If you don't have any maths background, this is probably getting rather brain numbing. So, check, and only pay attention to the absolute values, the magnitudes. Yeah. So the point is, if our old hspeed is minus 5, we want to start at 0, we want to go minus 1, minus 2, minus 3, minus 4, minus 5, and no further than that. We don't want to go to minus 6. In fact, yeah, it doesn't really matter whether we stop at minus 5 or minus 6, because it's only 1 pixel difference. So, is there anything still wrong with this? Yes. Is there? Maybe not. The thing that's potentially still wrong with this is this will stop us in just the wrong place. If we do go once, so this check here, if place meeting x plus hspeed, y O solid, that says with the current hspeed, our adjusted one, the one that we've been creeping up and up and up, if just adding that on and keeping our y the same hits something, then stop this loop. We only want this loop to continue while that's not true. And so that means that when it stops, at the end of this loop, when we get to here, fuck, we've already hit something. Because either we've got to fulfill one of these two checks, right? If we get all the way to here, then great, we've got some free space. But if we fail this one, whenever we fail it, we have gone too far. Our hspeed is too big. So we added 1, or subtracted 1 too many times. So actually, before we add this, we want to check. That's actually the thing we want to check, is if we increased our hspeed, would that be too much? So instead of just using the current hspeed from the previous iteration of this loop, we want to add on that plus the sine of it. So if this was, if our old hspeed was minus 5, and there's a collision at minus 3, or minus 4, let's say, minus 3, I'm not helping, am I? Then this would say x plus our current thing, which is like minus 2, plus another minus 1, which could take us to minus 3. If that's a problem, then stop now. Don't do this. Because remember, a while statement is like an if statement. If this is false, it won't do this. And so we want to stop before we do this. If there is a collision at that thing, then don't do this thing. So in fact, let's modify our comment to reflect that. Check there's still room if we crept a bit closer to our old h speed. That's what we're doing, we're creeping closer to our old h speed. And we want to check if we did creep closer, if we not only used our current h speed but added on a bit to try and get towards the old one, would that cause a collision? And if it does, don't do it. So we're testing, can we do this? If we can, then do it. If we can't, then stop. I think that might be it for h speed. So I want to check, I won't try and add anything more complicated to this before we test, but I'll just copy and paste the entire thing and we'll just go through and change it all to v speed instead. So we're going to do it first for h speed, then for v speed. And we will, no, sorry, not that. Do you know what, let's not do this yet because it's going to get pretty complicated, so let's just try and test this by itself. Can we do that? Old speed we define before we use it. This will always terminate because HB goes from 0 to this. If, hypothetically, if we had no h speed, if our h speed already was 0, then old h speed is 0, h speed is 0, and as soon as we get to here, we fail that check, because h speed is not less than our old h speed, it's the same. So nothing will happen. So that's good. And yeah, so this loop will always terminate, I believe. Let's just try it. And if it works, what will happen? If it works, we should be blocked horizontally. Yeah, that does work. But yeah, so we're not blocked vertically, but we are blocked horizontally. That's a perfect illustration of what we've just done. We've only checked the vertical part, the horizontal part. And best of all, so I am holding down right now. If I press up or down while still holding right, it works. I go up or down. So we have managed to retain this part of our speed that would otherwise be, that doesn't cause a collision. Whew, it's like language hard mode trying to talk about this stuff because every little thing is so technical. So now we are going to copy and paste this entire thing, and this will all be just grunt work. This is everywhere we said h speed, we want to say v speed. I'll literally go through and just replace every instance of that, except that one. So in every case we want v speed, even in the comments. But this part, obviously, we could change that to v-speed, but we wouldn't add v-speed to our x coordinate, obviously. We want to get rid of all of that, stay at x, and say y plus our v-speed plus, this should be old v-speed now. And we'll replace all of those with old v-speed. And so, that is now the exact equivalent of that. We've just done the same thing there. The only thing, and I've tested it both ways because I've tried this code before, and this seems to work fine, but after I thought about it I realised actually, since we've already established that we've already set the h speed to what we're going to keep, at the end of this thing, I'll write a comment here, we have now figured out how much of our h speed we can keep without hitting anything, so we're keeping that. That means we are going to move that much in the x direction. So really, if we want to do a fair check here, we should be adding that on, because we haven't moved that yet. We've kept our h speed, but we haven't applied it to our x coordinate. So the positions we're interested in are, we should take into account the fact that we're going to be adding this h speed. It'll be less than it was before, probably, if we've reduced it, obviously. But we should factor it in here. So, like I said, it seems to work without that, but I imagine there's probably some edge cases where it would cause it to fall down. So let's hope I've done my copy and paste job correctly and see if that works. If it does, that'll be it. This is all we're doing. Collision is easily enough for one episode. So that still works. And now vertical collision works. And while I'm holding down, I can still move left and right. This is awesome! Fantastic. And look, enemies are bouncing off stuff, and I'm going to pick up 2 guns, and both of those guns are going to respond correctly to all this solid objects, and enemies bounce off it, and I'm repeating myself, and you can shove enemies into it, which is fantastic. Obviously that's a bit of a glitch. Like, it's good that you can shove them into it a little bit, but they should pop back out somehow, so we might need to think about that in future, but that's beyond the scope of this episode. So this feels really nice, the smoothness of the solid objects feels really good. This would work fine still if you had a more free-form movement system where the player always went towards your cursor, or you were using tank controls and steering left and right. Tank controls, obviously, you particularly got to watch out for that rotation thing. Make sure you're not changing your image angle, because then you could rotate into a wall. I love this guy. And, oh yeah, one last thing to mention is that you can kind of get a bit stuck on corners. Like, not properly stuck, but just the keys that you expect to respond don't respond. Like there, technically I can't go down or right. Feels like I should be able to. It feels like when I press down as a player, I kind of expect to slip around the corner a little bit to make that work. And that doesn't happen. So that's not really a bug. Our code is doing everything we asked it to. But it's something you could improve if you wanted this to be perfect. Getting Collision to be perfect is a bit of a fucking rabbit hole. You could spend years of development doing it. And it's really boring too. It's like just really fiddly and messy, and you can never quite visualize what's really happening. So this system we've got right here, it's actually a very short piece of code, much shorter than what I had in Gunpoint. And it works for our purposes pretty nicely, I think. So we'll leave it there.